Let's wait for 5-10 minutes and then we can start the lecture. Okay, so let's start today's lecture then. If someone can let me know if my screen is visible. Is my screen visible?
Yes, sir.
Okay, so so we left our linear regression and logistic regression in between, and we did some math before coming back again. So today we will actually look linear regression in more detail. So let me just start with linear regression. So we have seen machine learning is a field of study that gives computer the ability to learn without explicitly programming the system. So we have machine learn, we have some data. We want to train a machine learning model such that it can identify patterns in the data. You want to find some insights from this unknown data, or you want to make some informed decision with using this data. So we also saw that machine learning can be broadly be classified into unsupervised learning, supervised learning, and reinforcement learning. In which the unsupervised learning we have given in supervised learning. Let's just see from supervised. You have a data and the corresponding label, and you want to learn a classification task or a regression task on the supervised data. In unsupervised learning, you only have data, you don't have the label, corresponding label. You want to do some clustering, dimensionality reduction, some form of insight from this data. Reinforcement learning, here you do not even have any data, you just simply have a feedback from the environment. In this entire lecture that we will be seeing only these two, the supervised learning and unsupervised learning, and reinforcement learning we will not be covering. Okay, so this is machine learning. And we also saw supervised learning and unsupervised learning. Given a data, if your data is continuous, we have a regression task. If it is a categorical, we have a classification task. And in unsupervised learning, if you have data that are continuous, we actually can do dimensionality reduction, categorical data. If it is categorical data, you can do clustering. Even continuous data can also become part of a clustering, but we most likely study categorical data in clustering form. Okay. So now a question though, what kind of a problem is this? Given which is of a vector x1 and x2 features, and you have a corresponding label 0. Now, given this task, you need to predict 0 or 1. What kind of a task is this? Is this a regression task? Is this a classification task? What task is this? Uh, if someone is saying I can't hear you clearly,
So classification.
it's a classification task, right? It's a
Yes.
classification task. Because you just need to predict either the label is 0 or 1. It is not a regression task. Regression task, okay, now let's do something else. Let's say, now this is label. Now you have a temperature term. Say, for example, this feature represents some city information, and this is a temperature term, temperature of the city. Currently, it is 32 degrees Celsius. Say it is 30, I don't know which, it's very hot there. You have 20 degrees Celsius, say 20.7 degrees Celsius. And what is the value here? So, what is this task? The temperature task. What task is this? What task is this? Classification or regression? What task?
Regression, sir.
It's a regression task, right? Can someone who said regression can also explain why it is a regression task? The person who said it's a regression task, can she also explain why does she think it's a regression task?
Sir, classification have two class, something like that.
And regression doesn't have two class?
No, sir.
Okay. Now, you are correct though. In regression, you actually have a continuous values. You see there are like 32, 39, 20.7. The value in this for this temperature, it can become say 25.73. You might end up predicting this value. You can see it is a continuous value, right? It can lie between any number between, say, if it's a real environment, most likely it will not go below, say, 10 degrees Celsius. At least in India, I don't think we have 10 degrees Celsius till say 45 degrees Celsius. Maybe in some cases it goes to 50. So 50 degrees Celsius. So most of your temperature level between minus 10 degree to 50 degrees Celsius, and it is a continuous value. It can you can predict any number in between this. The number can be 9.73 degrees Celsius. So this number can be this number, but it's a continuous value and you do a regression task. But if there are fixed set of labels, so the label can be not 0 1, but say it can be cat, dog, uh, horse, camel, so many classes are there. So but it is like a discrete set of classes. You can count those classes. There can be say 10 classes, 20 classes, 100 classes, but there are countable number of classes. So there are countable number of classes. So we call it a prediction task. When there are uncountable number of outputs, then there is no hope you can do classification. There is only you can do is a regression problem. It's a regression problem. Okay. Now everyone is okay with this. What kind of a problem is a regression problem? What kind of problem is a classification problem?
Yes, sir.
Okay. So yeah, so this is now let's look into the other problem. What is this problem? So you have an ID, employee ID, their education background, their professional training, and their hourly rates are given to you. What kind of a problem is this? Given a new education background, some professional training, predict its hourly rate. What problem is this? Classification, prediction, what production problem is this? What problem is this? Classification task or regression task?
Classification, sir.
Sir.
Okay. Someone else wants to say something? One of you said classification. Anything else that anyone wants to add? Or everyone thinks it's a classification problem?
Yes, sir. Classification.
And why did you say it's a classification problem? Because you think that these numbers looks discrete.
Yes, sir.
Okay. So you think that the hourly rates are always say it will become 70 till 130. So right, and there are like 60 such numbers, 60 such integer numbers, right? Therefore, you just have to predict one of those 60 such numbers. This is what you think? Oh, it is actually from 65 though. So there is 65 here. So assuming there are 60, I can't write anymore. So, uh, so assuming there are 65 such numbers, 65 such number integer numbers, and you need to predict among one of these, and that's why you call it a classification task.
Yes, sir. I think in that way only.
Okay, but think in this way: it's hourly rate. The number cannot be always be integer. What about the number is like 61.5? Ma, why 61.5? Because this person may be working for 8 hours And if you multiply with 8, you will have some integer numbers, right? Right?
Yes, sir.
So it can be some decimal numbers too. So the hourly rates, even though output seems to be like, okay, all looks integer and it's the values are always in between this. So there are only 16 integers, so it just predicts 60 such numbers. But you are missing the point that look at this thing. What is it predicting? It is not predicting a number between 0 and 130. It is predicting any value between this. So it's a hourly rates. It's a regression problem. If you solve, there is no harm in solving into a classification problem. But if you solve using a regression problem, your accuracy, or you will be able to better predict its actual rate. So what about, so if you predict some person's hourly rate is say 68 point say 6 let's assume 61.5. This is what you're predicting, and through, if you do classification, so how much if you predict this and if you multiply by 8, 8 hour work, what is the value here? 43. So this is the amount that you will pay. Okay, a into 8. Okay, now if you change this to say you predict through this classification thing, you predict 62 rupee. You say that you will predict 62 into 8, you will predict 436 rupee. So there is an error of 4 rupee margin extra, right? You are paying for, you are predicting 4 rupee extra that you will be paid when compared to this place. Even though this place you don't see, but what if it was like for 10 years or so? So you multiply with say for 10 days, it became into 10. Now it is 4,320 rupee. It became 4,360 rupee. Now the margin has become 20 rupee difference. It was like for 100 hours or so, and the margin became like for 200 rupee. So if you solve it using a regression, you will be slightly be more accurate compared to the classification task, because in classification you cannot predict the decimal points, right? But you can, but you just need to increase the number of prediction thing. So it is much harder to do classification when your sets are continuous. So when you look at the problem, please also look at what are you trying to predict. If it is an hourly rate, most likely it is a continuous value. And if it's a continuous value, you should try to use a regression model than a classification model. Make sense? Should I repeat again, or this makes sense?
Okay,
Let
sir.
me re-say this. This hourly rate is a continuous value. Most likely it will be a continuous value, right? It will not be a discrete value, most likely. First, try thinking what are the things that you are trying to predict. So, say if you're trying to predict hourly rate, or say if you're trying to predict whether, given this education and the professional training, will he be promoted to director or not? Yes, no. Director promotion. Will he be promoted to director promotion? Okay. DPROP. So you can see there is like exactly two label. Yes, no. Let's make it even more interesting. If this guy will be promoted or not, and what he will be promoted to. So he will become a manager, he will become a director, he will become a VP, he can become a, say, employee level 1, employee level 2. Okay, so now you see that there are like given this education and professional training, he can become manager, director, VP, or employee level 2. So there are like 1, 2, 3, 4 classes. But what is the hourly rate? It now becomes a continuous value. It is no longer discrete. So if your prediction lies in a continuous range, more likely if you use regression models, you will do better. compared to classification task, compared to classification modeling. Make sense? And if you do in this case, there are discrete set, and if you do a classification task on a discrete set, you will have a better prediction. Is this okay? So
Yes,
always
sir.
try to look at what are you trying to do. If this value is continuous, do regression. If this value seems to be discrete, if the question is like predict this and it's a set is discrete, it's a classification type. If the set, if someone is asking you to predict the hourly rate and the values looks continuous, it's a regression task. So always look at what you are trying to predict. Okay, so this is the type of problem. Now let's look into what are these. So first, you need to understand your problem and the data set also, and then you should extract some useful features. Remember that we did once credit card fraud, where we did, okay, we should have age information there, education information there. We also have some what time transaction amount that you are using, transaction amount you are using. We also had what time of this transaction was used, and then we added gender, which everyone unanimously said this gender information is not needed, right? So
Yes,
what we did was the feature extraction. So we were extracting what features is useful for us to do credit card fraud detection, right? This is what we were trying to do. So you should also extract useful feature. Once you understand what is your problem, there it becomes important. So if the problem was of fashion, like predict whether this dress is uh, good for this person or not, there age is important, and so is gender too, right? Because you want to recommend this, say this fashion product, this fashion clothes, some this fashion cloth to this person, gender information becomes important now. Like if she's a woman, then probably you want to show dresses that women will generally prefer. If he is a guy, you will generally try to show a different set of clothing attire. So there, gender information becomes important. But in credit card fraud detection, the gender information you can drop. You may drop. Make sense?
yes,
So
sir.
depending upon the what problem you are looking into, you have to design what different kinds of features though, different kinds of data set. You have to look into the data set, you decide which features are important for your task. Once you have identified your features too for the corresponding problem statement, try looking into what is that you are trying to predict. Is it a continuous task? Then you have to do regression. If this is a classification task, you have to do classification. If it's a discrete set prediction, then it's you have to do classification task. So also try after that you should look into what kind of problem you have trying to solve. Once you have decided it's a regression problem, choose a regression modeling. If it's a classification task, choose a classification modeling. You have to choose a right set of model depending upon what problem type, feature, and the data set you have. Once you have a right model, you start training and testing your model. We will look into how do we test and train the model. And then once you have a test and train, we try to improve the accuracy of the model. And then repeat. We go back to modeling. From here, once we have accuracy, we go back and try improving the accuracy by fine tuning our model or maybe choosing entirely different model. Okay, let me rewrite this. So once you have tried this, you go back and choose your model or improve your model. This is how it continuously flows. So once you have accuracy, some accuracy or something, you go back to the modeling part, either change your model or update your model, and then again train and test your model, how good your test accuracy is, and then see if you can improve. If you can improve, go and change your model, maybe change some hyperparameter or probably change the entire modeling part, and then
continuously do, and till when you have like when you are satisfied with this accuracy, or much better, when your stakeholders, the person who is going to use your model, is satisfied with your accuracy. Okay, so this is how the general flow of machine learning is. Okay, so let's move on. So you have what does test and training of a model mean? So you have in training, say you have some data set, you divide your data set into two set. You have a test set where you have 60 to 80% of the data, and a test set where you keep like 20 to 40%. Training set, you will with this data set you will train your model completely. So you will train your model exactly on this train set, and this test data set, the 20 to 40% of the data set, the model has never seen this data. So we want to predict, we want to find on this unseen test data, how accurate is your model. If your model is accurate on this unseen test data, like very accurate, say that your on test data, your model is 90% accurate. And this is model one on test data accuracy. Like it is 90% accurate. It is able to predict 90% of the task properly. There is another model. It is able to with accuracy. It predicts, say, 99% accurately. Which model will you choose? Model one or model two?
Model 2.
Model two, right? It is easy to see that you will choose model two to predict. You will choose model two for your task. Say it's a credit card fraud detection, whether this financial transaction is a fraud transaction or it's a it's a okay transaction. And model 2 is able to 99% of the time it is accurately able to tell you that. So you will share model 2 with your manager, saying that, oh, I have this model 2, you can use this model to detect fraud, right? Now let's look into this, why we need test and train data. What about, say, there is a model 1 and you have this train accuracy. You have this train accuracy of, say, 98%. The model 1 gives 98% train accuracy. Model 2 gives train accuracy of 95%. Notice this is training accuracy, meaning this trained data is there. You trained your model on this trained data, and your report in this trained data, your algorithm, your model has seen these trained data. You take one of the trained data, and not one, like the full trained data, and you try to predict if there is a fraud or not. This trained data, we are still doing the credit card fraud detection. This is fraud detection task. Okay, we are still doing the fraud detection task, and on trained data, your model 1 performs 98% accurate and model 2 is 95% accurate. Which model will you choose?
Model 1, sir.
Anyone else? Okay. So if people, someone said model 1, the answer is we can't say anything. Even if the model 2 accuracy is 90%, we can't say anything whether we should choose model 1 or model 2. Simply because the trained data, it can simply mean that the data that is there, like your model, the machine learning model has seen these data, and you cannot say whether if there is unseen data, that if there is a new data that comes to this machine learning model, will it be will it be able to will it be able to uh, someone can switch off the This is a mic, please. How do I switch off the mic? Mm, okay, thank you. Uh, yeah, so here the train data set, the model has seen all these data set. The model has seen all the train data set, and that's why it is giving you a prediction of 90% or 98%. What if there is a new data set that model has never seen during training? Will it still be able to give me that this much accuracy? That's why we need test data. The model has never seen these test data. If rather than train data, it was the test accuracy, like test data accuracy. Like the model has never seen these data while training. And on these unseen data, the model 1 performance is 90% and model 2 performance is 90%. You can say that we will select model 1. We cannot say anything just by looking at the trained data. We can say that probably model 1 may perform better, but we cannot say anything for sure. But in test data, you can say that for sure that, okay, model 1 seems to perform better compared to model 2, if it is a test data. In trained data, you can just hand wavingly say that, okay, model 1 can perform better, but nothing can be sure. Model 2 can also perform better too. It is only in test data set where the model has never seen such data and your accuracy is reported on test data, you can say anything which model is better. Is this part clear? I can repeat again why we need test and train split. Is this part clear?
Yes, sir, clear.
Okay. Okay, so let's move on. So now let's see is what kind of problem is this? Given this problem, answer this question. So you can read this question and which are the options. This is option 1, option 2, option 3, and option 4. So which is the correct answer?
Options.
Option 2, this option. Okay. Anyone else? Which option they want to try?
Option 3, sir.
So there is someone who says option 3. Anyone else that wants to try?
B, sir.
B, option 2.
3.
Option 3. Okay, option 3. Uh, anyone else? We have like more votes for option 3, it seems like. Anyone wants to vote for option 2? Option 1, option 4?
Option 3, sir.
Okay, there is another vote for option 3. It seems like option 3 is popular now. Anyone wants to choose option 1, 4, or option 2? Increase the popularity of 2. Okay, so let's see. So the students who have answered option 3 is the correct answer. Let's start. Again, why? No, first start with the person who has chosen option 2 as the correct answer. The student who said that option 2 is correct, can they uh, uh, justify why do they think option 2 is the correct answer?
Sir, in problem one, predict how many of these items. So the item is countable, sir. So I choose first option as classification. And problem two is individual customer account. So we don't know the how many customers. So that I choose the regression, sir.
Hello. Am I audible?
Yes, sir.
Okay. Let's start again. So the person who was answering, why do they think the problem option 2 is the correct answer? I'm sorry, our internet got disconnected. Please continue.
Sir, in problem one statement, predict how many of these items. So these items are countable. So I choose first option as classification, and problem two, uh, customer accounts to decide hacked or compromised. So I don't, uh, how many customers are there. So I choose that regression options.
But it is not how many customers are there. It is like to decide whether it is hacked or not. Right? Given a customer account, whether it is hacked or not. So still a regression problem? Hello? The problem too is like given you would like software to examine us individual customer accounts, for each account decide if it has been hacked or compromised. So given a person's account, you want to predict if it is hacked or not. So do you think it is a regression problem? You want to are you able to hear?
Yes, sir.
So do you think it is still a regression problem, or do you want to choose like both classification, option 1? No, please answer, Dhona. It would be easier so that I can also see which part it is not clear, which part is difficult to follow. You can see, right? Here there is only two options: whether if this person's account is hacked or not hacked. So it's clearly a classification problem. Everyone can
Yes,
see
sir.
that problem 2 is a classification problem. It's
Yes,
not
sir.
a regression problem. Hello. Let me reshare my screen. So there is a power cut here constantly. So that's why it's getting disrupted. So people who chose problem one as a regression problem, can they share why did they choose problem one as regression problem? I can see problem two is a classification problem. There are only two classes, hacked, not hacked. But problem one, why did they choose regression?
Sir, at the last cell over that next 3 months, so the continuous values takes place.
So why is it a continuous value?
Sir, next 3 months, so
It can be like
continuous.
1, 2, 100. Can they sell like 100.1?
No, sir.
So what is continuous value here though? How to predict how many of these items will sell over the next 3 months? So can you sell 100.1? Can you sell 10.2 of these items?
No, sir.
So why did you choose regression then? It doesn't seem to be a continuous though. The person one who said that there are still large values, but it is still discrete values. So she chose classification. And then she chose that the problem two is also classification. So she updated her answer to both classification problems. I'm assuming this is the first person who answered problem one is classification and problem two corrected to classification. But there are sufficient people who said problem one is regression. Uh, did you choose regression because you felt it is a continuous problem? But it is not, right? Anyone else who wants to answer why did they choose problem one as regression problem?
Sir, problem one is predicts a numeric value, so it
Uh-huh.
is regression.
Problem one is numeric value,
Yes, sir.
but
So
it
it
is
is
like, but you can see this thing that you just have to predict between these classes 1, 2, 3, 4 till 100. You just have to predict which one to go to, right? You just have to predict either it belongs to class 1 which has 1, either it belongs to class 2 with which will predict okay 2 values, either it belongs to class 100 which is like 100 things have sold. Still
yes, sir.
discrete, right?
Hmm.
You are able to see, right? I'm not writing cat, dog, mouse, and horse. You are not asking you whether this image is cat, dog, mouse, but it is still like you are actually asking whether it is 1, whether it is 2, whether it is 3, whether it is 4, or whether it is 100. It still feels like a prediction problem, a classification problem. Because these numbers are discrete numbers. Anything in between, you don't have to predict like 2.734, right? There is no such number in between. That would make you feel like, oh, it's a continuous value and that's why we should use regression. But these are still, you can make it like a class that, okay, I just need to predict whether it belongs to class 1, which has 1, whether it belongs to class 100, which has 100, right?
Yes, sir.
Yes, sir.
So why, anyone else wants to try why you thought that it is a regression problem? Or everyone now wants to move to classification problem? Both classification. Okay. So let's answer this. The answer is you can treat both as classification and one as a regression and two as classification. And in general, if you consider problem one as regression problem, that would be better though. Treating both as classification problem would be a difficult thing to solve, especially the problem one. If you use it as regression problem, it is better. Okay, let's look into this. Why did we say such things? So the people who chose option three, I think they did the right thing. Even choosing option one was also not bad. Why do I say that the cell over this can become a regression problem? Look, why did we even start by choosing a regression problem? It was not not just the continuous value. So if you have to predict 1.2, 1.7. It became like so many values in between to predict, right? If you have to predict between a number between 0 and 1, there are infinite such numbers between 0 and 1, right? So it must be a regression problem because you can't predict infinite numbers in between. Is everyone with me, right? Say for example, if you have to predict, let's do a regression problem. Some is something p is there, some input you pass, and it predicts a value between 0 and 1. Between 0 and 1 you have to predict. So if you make a classification problem, you will have to create label. So say the label is 0, you will put 0.1, then you will put 0.12, then you will put a label 0.13, and then so on to 1. And you will say that, okay, if I given a p, I will just find a value between this. I will try to predict a value between this, like do a classification problem. But what about if the value is not in between this and the value is 0.125? In classification, if you make it a classification task, you will never be able to predict this value, right? Because this label is never there in this set. Everyone is clear with this part. Why classification will fail here? Because there are infinite number of values in between 0 and 1. And to make a label, you will have to create a discrete set. And if you create a discrete set, you can never be able to predict 0.125. Or if there is some other number that is, say if you add 0.125, then you will not be able to predict 0.1259. You will not be able to predict this number, because it is never there in the set. Even if you add this number, I will add 1. You will not predict this. Okay. So the reason that you are finding it hard for a classification task in a continuous value is because there are very large number of there are infinite number of numbers between 0 and 1, right? There are infinite number of numbers, right? So to make a classification task, you need to create this infinite set and then ask your model to predict in this infinite set. Is everyone with me till this point?
Yes, sir.
Okay. So the reason that you are choosing to do a regression when there is a continuous value, because if you create a classification, there will be an infinite number of labels there, and you will not be able to learn a good model. Similarly, the problem 1, how many items you will sell? You can sell 1 item, you can sell 0 item, you can sell 1000 item, you can sell 10,000 item, you can sell 10 item. The number that you can sell here is very large. Make sense? The number of elements that you will sell is very large. Like this, the set, you can sell 0 item till say you can sell say 10 to the power 7 items, any number in between. And 10 to the power 7 is not so big, though. It's only 10 lakh, right? No, 1 crore. It's around 1 crore. So you can sell either between 0 item till a very large corporation like Reliance or so, they can easily sell so many items though. Or say 10 to the power 6 or 10 lakh, if 10 to the power 7 feels like too big. So 10 lakh items. So any number between 0 to 10 lakh. So you can see that there are infinite number of items in between to predict. The reason we chose that some problems should become a regression problem because the set of labels becomes very large. And in this case too, even though problem 1 looks like a discrete problem, but the number of labels that are there in this set is close to infinity, right? You can consider that this number is very large and not infinity. So this number is much, very, very large. So you can consider problem 1 also a regression problem. And in general, this is what people also do. They consider this problem 1 as a regression problem. Everyone is okay why we can treat problem 1 as a regression problem?
Okay, sir.
No, not okay. Were you able to follow why we should treat such thing? If there in future you see such thing, how will you decide problem 1 is a regression problem? Now, can someone explain why problem 1 is a regression problem? The person who said okay, can she explain why is problem 1 a regression problem?
So just now you told the set of labels are too large.
Yes. If the set of labels are too large, like it's very large, then it is better you consider this problem as a regression problem, because regression is used to ensure that if there is not just a continuous value, when the number of labels becomes close to infinity or so, it is difficult to do classification anyways, because whatever class you bring, it is not there in the set. It may not belong to the same range though. So you do regression. Similarly, if the labels, even though they are discrete, but if it becomes too large, you can consider making it as a simple regression problem too. So that's why 3 is also right and 1 is also right. 1 in general people don't prefer, but yeah, sure, you have discrete sets, you can create this thing. Numbers will always be between 0 and 10 to the power 6 if you know the upper limit. But in general, they consider to make it as a regression problem. Okay, so let's move on. Okay, this example, what is the answer for this? You have 1, 2, 3, 4. Which one? Which option should we select? People can guess too. So
I
share.
think two, sir.
You think 2. Okay. Anything else? It's multiple correct though. Check all that applies. Anything else?
2 and 3, sir.
2 and 3. Anything else?
4, sir.
4. Someone said 4. Okay. 4, 2. 1. No one. Okay. So a person who answered 4, can she share why she chose 4?
In unsupervised learning, there is no label, sir, only data, so we can identify anything from the data. So I choose option.
By the way, but I think what you said, based on that, you should not have chosen 4. Here, the data set contains the label. So you have a data set of a patient that is diagnosed as either having a diabetes or not. So the data set says that there is a patient P1 and it has whether the patient has diabetes D or D bar, whether the patient is not diabetes. This data set is there in this data set, patient and the label, and the goal is to learn Hello.
Yes, sir.
Okay. So let me share my screen again. Sorry. So we were saying, so in this data set, if you look at this data set, you have a patient data set and whether the person has diabetes or not. And the goal is, given a new patient that comes, you need to predict whether it has a diabetes or not. So it is clearly a classification task, right? Is this clear?
Yes, sir.
Did we lose internet again? Am I still audible or did I? Oh,
Yes, sir. Audible, sir.
okay, okay. So this option 4 is a classification task, right?
Yes, sir.
And you have the patient data and its corresponding label. So it is not a supervised learning task, right? People can see that this is option 4 is not a supervised learning task.
Yes, sir.
Okay, so option 4 is gone. Why is option 1 not correct? Because here again, given an email
Mail is
labeled as
labeled.
spam, everyone can see, right? The label is also given for the corresponding email. Therefore,
Yes, sir.
in supervised learning, we don't have labels, so option 1 is also gone. So both option 1 and 4 is not there. Now let's read option 2. Student who answered option 2, can someone share why did they choose option 2?
Sir, just clustering of words.
Exactly. It's just a simple clustering algorithm. And clustering, here you have news article and you just want to cluster those articles which belong to the same story. There is no label given to you. So you just need to find some way of clustering these algorithms, and clustering is an unsupervised learning algorithm. Clustering. We will see clustering in our lecture. Now, student who chose option 3.
Sir, it is also group the data based on similarity, sir. So it is
Okay, so
clustering.
okay, it's also clustering. Everyone is okay with the answer that she gave?
Yes, sir.
Okay, so both option 2 and 3 are correct, and option 1 and 4 are not correct. Okay, so let's move on. Now we will look into the linear regression's actual definition. I just want to finish linear regression, and tomorrow we will do a hands-on session. Okay, so let's move on. With this, we have already seen. Okay, so now let's look into the math of linear regression. So you have these data points. So these data points that you see came from this equation where B naught is some number and B1 x plus U is some noise, like some noise is there. You add some plus 0.01. Okay. So you can think of this line as 2 plus 3x. No, 2 minus 3x. Sorry, I am wrong. You can think of this line as 3x plus 2 equal to y, and plus some noise, say 0.001, with plus minus some noise you add this. Okay, so this all these data points, this blue dot that you see is say generated from 3x plus 2 equal to y line, and you have added some noise into it. Your goal is that given only these data points, can you figure out what is this line? Your goal is to predict y hat is equal to some theta 1x plus theta naught. Your goal is to figure out theta naught and theta 1. And how do I figure out theta 1 and theta naught? This is what linear regression does. You want to fit a line that best explains this data. And if you know that the data came from this line kind of equation where u is some noise, then the goal becomes very easy, that what is the value of this theta 1 and theta naught. Everyone is okay with this part? Right? if you know that your data came from this kind of a linear equation with some noise, if you know that this, if your data came from some linear line, some linear equation with this noise, your goal is to figure out the coefficient of this linear equation. That's it. If you can figure out this theta 1 and theta naught, then you can figure out this green color line, and given a new point, you can approximately say what is the value of that point. We are doing regression. It's not a classification, we are doing regression now. So given a new point, you can definitely say, so given this new point, you can say what is the approximate value of y. Everyone is okay with this? Hello? Our internet got disconnected again. Am I still audible or internet got disconnected?
Audible, sir.
Oh, okay. I feel like internet has disconnected so often that I am lost now. Okay, so is this okay? That if you know that the data came from some linear equation, your goal is to figure out the coefficients of these linear equation. U is anyways noise, so we cannot actually figure out this U. But this is these two coefficient is the goal that we want to figure out. Okay. Yes. No.
Okay, sir.
Okay, if you have said okay, now I have another question. Now tell me what is this now? Say the data points looks like this. All these x's that you see are data point. You can see that it is not a linear line, right? It is something like this.
Parabolic.
Parabolic. So so you know that the data has come from some parabolic equation. You need to find out this parabola now. So let's write y hat is equal to theta 1, say right, theta 2 x square plus theta 1 x plus theta naught. Your goal is to figure out theta 2, theta 1 and theta naught. Correct? Right?
Yes, sir.
So if you figure out this theta 2, theta 1 and theta naught, you can figure out given this new random point, what is the value of approximate correct value of y. Everyone is okay with this?
Yes, sir.
Okay. So all these things are only possible if you know the underlying structure of the data. Okay, let's write something more interesting. Let's consider the parabolic example once again. So we have these kinds of data here, random data placed here, and you want to find this y hat, and this y hat that I wrote is of theta 2 x square plus theta 1 x plus theta naught. This is what we wrote. And if you see, this can also be written as in a vector form. Theta 2, theta 1. Since everyone has done this matrix vector theta naught transpose x1 square. No, sorry, there is x square, x and 1. Is everyone can see this thing? Y hat can be written in this form. Can everyone see this?
Yes, sir.
Everyone can say this, right? You can always do transpose if you write the theta 2 into x to x square, theta 1 into x and theta naught into 1, which becomes this. Everyone is okay with this part? Okay. So if this is the case, so you can always write your linear equation. So your prediction y hat is equal to some theta. This is a vector now. Some theta transpose and your x. You can write x square, say you can make it like, no, why make it square? You can make it like x to the power 3 2, x cube, x square, x to the power 1, and 1, x to the power 0. So what is the size of theta hat? It's the size of 3 cross 1, right? There are 4 cross 1. Right? There are 1, 2, 3, 4. 4 variables should be there. 4 cross 1. Theta bar I am talking about, not theta transpose. Theta bar becomes 4 cross 1. Theta transpose becomes 1 cross 4. And then it becomes a distance. Is this okay? Hello?
Sir, I have a doubt.
Yes, please.
Sir, why transpose is there?
Oh, why? Oh, you forgot. I see. You remember we just wrote y hat is equal to theta 2, theta 1, the quadratic one, the parabola, the people said. Transpose into x square, x, and 1. Now do this multiplication and tell me that this transpose is needed or not. And this part, this is called theta vector that we are reflecting. Since it is a theta vector, so theta bar is becomes a vector which can, its values are theta 2, theta 1, theta naught, transpose, and this is the x vector, the x square vector. So we call it capital X vector, and we call it y hat. This is what we are writing. Is this okay with everyone?
Yes, sir. Clear, sir.
Clear? Okay.
Yes,
So
sir.
now the only problem is that you can, it's not just x square. We can make it cube too, right? We can make it any polynomial degree. Correct? We can make it to any polynomial degree. Everyone agrees to this fact, right? We can make it to any polynomial degree. Why 2? Everyone can see?
Yes, sir.
We will come to learn this, which polynomial degree is a better choice, but we will see this part later. But we, in general, you can see the point what I was trying to say is that you do not have to necessarily think that it can only fit a line. We just saw that we were able to fit a quadratic curve too with just this linear equation. Why is it called a linear regression? Because there is this a theta transpose times x. Now we will come into a into b equal to y, ax equal to b form. We'll see how it becomes a ax into b form, and since it becomes a ax into b form, it becomes a linear. It's a linear equation, right? System of linear equations. And we know how to solve this. Is x is equals to a inverse b.
B.
Yeah, we know this thing. So we will just write this form and then we have a solution. So x can be any degree though. It is no longer a linear. It is not just a linear line. You can fit quadratic, you can fit x cube, degree 3, degree 5, degree 7, degree 10. Whatever degree you want, you can fit those data into that degree. Linear regression does not mean you can only fit a linear line. It can fit any degree polynomial too. Everyone is okay with this part?
Yes, sir.
Okay, now let's solve this problem. How do we find this theta? Now x is just a vector, right? And this is also a vector. We can't actually inverse a vector though, because it's not a square matrix in the first place. Okay, this inverse is only exists for a square matrix. Now let's see what is there though. There are other things too. So all these data points that you see, this is data point 1, this is data point 2, 3 data point, 4 data point, 5 fifth data point, 6th data point, 7th data point, and similarly there are like so many 8, 9, 10, 11, 11th data point. So there are 11 data points, right? Now for each data point, what we want is that your theta, this is like theta vector transpose the first x1. This is x1 vector. So x1 vector, when I write it is like x1 square x and 1. So x1 square meaning this 1th point, say the x1 value is say 2. So it became 2 square, 2 and 1. The second value, say it is 2.2. So it becomes 2.2 square. Understood, right? X2 vector. So x1 vector, x2 vector, you have x3 vector, and similarly you have x11 vector. Everyone is okay with this? Everyone, any doubt what is x1 bar vector? What does it mean? There are 11 points and each x1, let's write this. X1 vector simply means x1 square, x1 and 1. Assume that we are fitting a parabola on this data point. This is okay?
Yes, sir.
So x2 bit x1 meaning, say if this is the point that you are referring to, so x1 corresponds to 2, say this x1 is equal to x is equal to 2, so it becomes 2 square is 4, 2, 1. So the first x1 point value is 4, 2, 1. Say x2 is, say it is, say let's write it 3 for simplicity. X2 vector, what will be x2 vector become? 9, 3 square 9, 3, 1.
1.
Say x11 is, say 10. So what is x11 vector? 100, 10 square, 10
Mhm.
and
1.
1. So what you have to do is x1 you have to put here, x2 you have to put here, x3 similarly, and x11. So all these numbers you can put, right? Because it's simply a vector now. You have created a vector of a vector with polynomial. You want to fit a polynomial curve here. So remember this y hat, we want to fit this polynomial. Theta 2 x square plus theta 1 x plus theta naught. We think that polynomial will fit, even though we know that this is a linear equation, but we want to fit a polynomial equation on this data point. So polynomial equation looks like theta 2 x square plus theta 1 x plus theta naught. So if you put this value of x, it should give you the value of this y, whatever y it is, it should predict that value of y. And we want to find this theta 2, theta 1 and theta naught. Here theta 2, if your model is accurate, your theta 2 will become 0 and then it becomes a linear line, right? If you are able to learn this line, if your model is able to learn these data points, it will predict theta 2 is equal to 0 and then it becomes a linear line. So based on this data set, you want to learn a polynomial data set because you don't know what is this data point. So you are splitting your polynomial equation. You want to find theta 2, theta 1 and theta naught, and for that the x becomes x square, x and 1. So that's what you are writing. So first term became 4, 2, 1, second term become 9, 3, 1, and similarly the 11th term become 100, 10, 1. Everyone is okay with this part?
Yes, sir.
Any doubt in this case? Any doubt that you have that how did we write this x, big X matrix now? We wrote this into a big X matrix. There's initially X was a simple vector, now it became a big matrix. And the matrix size is, I will write the matrix size directly, 3 cross 11. Can everyone see that this has become a very big matrix of x bar 3 cross 11? So there are 3 points, x square, x1 and 1, and then there are 11 such data points. So on the column space you have number of data points. You have data points here. And on the x-axis you have features. So you have the feature is x square, x and 1. So this is for features, the rows direction you have features. And since you have only 3 features, x square, x and 1, so it is 3, and there are 11 data points, so you have 11. So the big X bar matrix is 3 cross 11 size. Everyone can see this thing?
Yes, sir.
No, I feel like the energy has gone down though. People are not able to see. Okay, if they are not able to see, I see we also are very close to time then. I think I will share this slide and we will pick from this place again. So we will, I will leave this part here and I will share this slide though. First, I will share this slide on the WhatsApp group and I will leave you all to this point that we will do this theta transpose x bar and we'll pick again tomorrow. And we will do the other proof that how to find this theta. We'll do all these things tomorrow again. So let's end this class today. I will share the just stay online so that someone can verify that if this slide is if they can see the slide on WhatsApp. We just share the slides now. Okay, can someone confirm that they can see the slides?
Yes, sir.
Okay, so we will continue from tomorrow's class, the linear regression and how do we derive all these things, and then we will go back to do tutorial, the Python notebook tutorial. Thank you again. Thank you, everyone. So we can end the class now. Thank you.
Thank you, sir.
Thank you, sir.